we're going to work on graphing the reciprocal of a quadratic. So essentially what that is our quadratic function is kind of on the bottom of this. So think of it like this. Our original quadratic, we'll call it g at x, would be x squared minus 9 over 1, and the reciprocal of it is the idea of just flipping the numerator and the denominator. Okay, this is a pretty simple one to graph. If you kind of remember your graphing of quadratics, I'll quickly pull one on the right here. But essentially, this is a quadratic that the vertex is on the origin and it's just at -9, and it's kind of not really stretched or compressed from the parent function. This is essentially our quadratic. Now this one here is going to have a very, very different graph. So because it's a reciprocal, there's a couple things we need to find out. We need to figure out any vertical asymptotes. We need to figure out any horizontal asymptotes. And then depending on how many they are, we might have to fill the spaces in between with some major points. So the first thing to do is define vertical asymptotes that we're looking at when the f at x or y is equal to the idea of 0. Her scratching is going to, what we're going to do, sorry, that is a y-intercept that I've just, or an x-intercept that I've just told you. We're talking, let me fix that. Not when it's equal to 0, but when it's equal to 1 over 0 is when we have vertical asymptote. So in other words, we're looking at when the denominator is going to be equal to 0. So I'm going to take just the denominator and set it equal to 0. So we have x squared minus 9 is equal to 0. So we need to find out what values of x essentially give us a 0. This is a difference of squares. Do you recall difference of squares? Yeah? Okay, so when I factor this is x minus 3, x plus 3 is equal to 0, which means our x values here are positive and -3. And because it's vertical asymptotes, the idea is that x cannot equal positive or -3. So in our rough sketch over here, we'll start kind of drawing it out. We're going to have, I'll put them in red, we'll say that this is positive 3 and this is -3. But we have vertical asymptotes at these points. So at -3 and positive 3, essentially our graph is not going to touch those. Okay. We also want to figure out if there's any horizontal asymptotes. One method for finding horizontal asymptotes is taking all of our values. Okay. So finding kind of like when, you could say when f is at infinity, you could say. So when it's getting close and close all the way to the end, they'll kind of let us know when our horizontal asymptote is. So when we're going to an extreme one way or the other. So our function is 1 over infinite value, which was our x squared, minus 9. Okay. So infinity squared is essentially infinity, right? If we subtract 9 from it, it's still infinity. And 1 divided by infinity is such a tiny number that it is approximately 0. Okay. So our horizontal asymptote here, we'll change the color, we'll put it in green. We have a horizontal asymptote at y is equal to that. Now, vertical asymptotes are very strict. You do not cross them. There are functions where the horizontal asymptote does get crossed. Okay. In this one here, I don't think that's going to be the case for us. And we would usually use calculus. And since this is an advanced function, we're just going to look for major points. So with that being said, I'm going to kind of build a number line here. Okay. So our number line, go from one end to the other there. We know we have -3 and positive 3 are, think of them like critical values. Okay. And actually, since we factored the bottom, I'm going to rewrite this original function factored underneath so we can kind of refer to it. So the f at x function is equal to 1 over x minus 3, x plus 3. Okay? What we're going to do is just kind of find out where the function is positive or negative. Okay? So one way you can go about doing this is taking values that are less than -3. Okay? So a value that's less than -3 is something like -5. Okay? So what we're going to do is we're going to look for f at -5 and just figure out if we have a positive or negative function here. Let's go back up. There we go. Oops, sorry. It's kind of lagging here. There we go. So when I put -5 in, -5 minus 3, that's going to be a negative. -5 plus 3, that's going to be a negative. So that's a negative times a negative on the bottom, which makes it a positive. That means we have a positive divided by a positive. So yeah, and we can actually get out whatever our value is, but what's important here, if we're just doing a rough sketch of it, is that at this point, go up, yeah, we're positive. In other words, we're above the y-axis, okay? So, or above that horizontal asymptote is really what we're talking about. So what that means is we're above. So if we're above, we can kind of use some inferencing here. We know if we go towards negative infinity, we're getting very, very close to the horizontal asymptote. We know we're not cutting downwards because of this horizontal asymptote. So we're essentially very close. We're going to approach this, and then we're going to head up because we don't touch the vertical asymptote. So the fact that it was above that 0 value lets us make some of these inferences here. Okay, so we come across, and we come up and head up like that. Okay. Our next point. Let's use a value that's greater than positive 3. So something like positive 5. And let's find out where it exists. Right? So f at positive 5 is equal to 1 over 5 minus 3, that's a positive. 5 plus 3, that's a positive. Positive times a positive, divided by a positive. Yeah, we end up at positive again. So, same concept. This one's positive, and we already tested our horizontal asymptote. We know that this function, as it gets towards infinity, is just getting really, really close to this horizontal asymptote. And because it's above, we know we're not cutting down, so we must be coming from up here, getting close, and then heading across. Okay?
Can you just draw? You don't have to find any points.
We can find some major points if we want, but this is if they're asking just for a sketch of the graph.
So you just draw.
Yeah, we can do it. And then we can find points along to really solidify our information. But this is giving us a rough idea, and then if we want, we can actually take the values, like, you know, we plugged in -5 and +5. We can actually find out what those coordinates are. Yeah, and that's usually one of the ones we'll do. We'll talk about that. We're finding it. So another idea, we want a value that's essentially between negative and positive 3. So we want when x is less than 3 but greater than negative 3. 0 is a wonderful value. It really does a lot, right? So same idea. Let's go down. F at 0 is equal to 1 over 0 minus 3. That's 0 plus 3. That's a negative times a positive, which is a negative. Positive divided by a negative, we have a negative value. So what that means, okay, we're below this horizontal asymptote, right, somewhere. That means when we're heading left, we must head downwards because we don't cross this horizontal asymptote. Okay, so it could do this. It could fire right down. Well, that's where finding critical points will be really important. So we'll find out what this local max is, whatever it is. And does it go straight down from there? Does it actually go really sharply and turn? That's where finding out the points will give us a lot more information. Is ours like a lot wider up here, or is it a lot closer to here? That's where we're going to go. And I haven't really put a scale here, so that's why this is still just kind of a rough estimate. But because it's horizontal, we know we're getting close, and then we're heading downwards. And same with the other side. It won't go up, cross that horizontal asymptote, and it can't cross the vertical one, so the only direction it has to go is down here. So we have the general shape of this. Okay, because this is a pretty symmetrical graph, we know that our local maximum is most likely going to be directly in the middle of these two vertical asymptotes. So we can use that value, and that value was 0. So not only did it get negative, but let's actually find out what the value of it is right now. So let's continue this. 1 over -3 times +3, we get 1 over -9. Okay, that makes sense. So our x value, because we plugged it in, our x value, give me a little room, was 0, and our y value was -1 over 9. So, and again, this is a rough sketch, right? Scroll on up. This coordinate here is at 0, -1 over 9. Okay, so that's where that coordinate is there. So there's a major point. And if we wanted, we could kind of go at 1 and 2 and -1 and -2 and get like a true definition of what this is. But with the math we know right now, we would actually have to go about plugging each of those values in every time to get a very, very exact model. Along with that idea, we could use 5. Usually a good value to use is 1 away from the horizontal, 1 away from the vertical asymptote. So instead of 5, let's use -4 and +4. That usually is kind of where a turning point or it's not an inflection point, but we'll just call it a turning point right now. Those are usually decent values to use. So let's go about doing that. Let's actually plug in our force. So you'll notice to find all these coordinates, all I'm doing is really plugging in values. I'm plugging in critical values to give me the rough sketch. But if I want some major points, we have our local, kind of a local maximum, and then we'll use f at -4. So let's do f at -4. -4 minus 3 is going to be -7. -4 plus 3 is -1. We're going to be left with 1/8. Sorry, 1/7. Did that make sense? I know I did the math pretty quick there. And f at 4, well, that's 1/4 minus 3 is 1. 4 plus 3 is 7. Same idea. 1/7. That makes sense. They're symmetrical. So our coordinates are -4 and 1/7. Well, I got to fix this way too slow. 4 and 1/7. So another major coordinate in our rough sketch of our graph. We'll say that this is 4. So 4 and 1/7. And we'll say that this is -4 and 1/7. So we can actually go about checking this. Let's go over to our graphing calculator here. Okay. So we have our graphing calculator here. Let's bring up pen. Okay. So as you can see, it's pretty flat looking, like we said, and it gets really close to these vertical asymptotes when we're between -3 and +3. And that's a 3. And like we said here, it gets really close to this horizontal asymptote, and it makes a turn and heads up. Same idea, comes down and heads this way. So let's actually go to our cursor here. Let's find out some of those major coordinates. So one of the major coordinates, -0.11111. If we pull out a calculator, well, let's clear that. 1 divided by 9, and it should be a negative, is 0.1111. So that's the exact value that we said it was going to be. And we can go across here at 4, or 0.143. And remember, we said it was 1/7, I believe. Yeah, so 1 divided by 7, 0.428. So they rounded up.
Yeah.
So really, we're just plugging in points to find out any of these other real critical values. The only true critical value here is this, local maximum, and then the horizontal and vertical asymptotes that are what's really important when we go about graphing this question. Okay.